Good afternoon, everyone. Welcome to the California Advanced Homes Program webinar on the future of high-performance windows and the California Energy Code. If you have a question, please enter it in the questions bar on the panel on the side of your screen. We will pause periodically to take questions throughout the presentation and again at the end. This presentation is being recorded, and we will send you a link to the recording as well as the slide deck later this week. My name is Allison Whitwer, and I am on the CAHP program team. My colleagues and I work for TRC, and we implement the program on behalf of PG&E. Any inquiries or correspondences with the program will be with us, but PG&E is the source of the incentives and the vision behind the program. CAHP is the single-family new construction program that offers incentives to builders for building more efficient and energy-conscious homes. TRC also implements a multifamily program with the same goals, known as the California Multifamily New Homes Program, also known as CMF&H. The programs are developed to help participants prepare for code changes and to strive for zero net energy. They are funded under the auspices of the California Public Utilities Commission. To qualify for the program, a project must be within PG&E territory for gas and/or electricity. You must be going above Title 24 Energy Code, and the homes must be single-family, duplexes, or townhomes. Energy consultants that participate in the program must hold a 2013 or 2016 residential CEA certificate. All right, so I would like to launch a poll really quick to see who we have on the webinar today. So I'll give you guys a few moments to answer that. All right, just another couple seconds. Okay. So we have, the majority look like we have energy consultants. There may be one or two HERS raters and developers, a few architects, and then some utility representatives. So thanks everyone for joining us today. So today we actually have three panelists. Mazi was not able to make it, but Nick will be presenting his slides. Robert Hart performs research and model development of energy-efficient windows and window attachments within Windows and Envelope Materials Group. His recent work includes the development and experimental analysis of highly insulating super windows, shading systems, and vacuum glazing. He holds a BS in Mechanical Engineering from Cal Poly San Luis Obispo and an MS in Mechanical Engineering from Stanford University, with concentrations in heat transfer and fluid dynamics. He is a registered professional engineer in the state of California and a lead AP. Brad Began is currently the CEO of Alpine High Performance Products, a manufacturer of high-performance windows, doors, and insulated glass products out of its Colorado facilities in Niwot and Denver. Alpine manufactures and sells some of North America's most energy-efficient windows, doors, and glass products for use in both residential and commercial projects throughout North America. Began first purchased Alpine in 2005, successfully sold the company in 2008, and then repurchased the company in 2012. Prior to purchasing Alpine, Began was the CEO of Metal West, one of the nation's largest Western-based metal processors and distributors between 1994 and 2005. Prior to beginning work with Metal West, Began practiced law in Dallas, Texas from 1985 to 1994. He holds a BA degree in History and Political Science from Texas Christian University and a JD degree from the University of Texas. Brad lives in Boulder, Colorado. Nick Dunphy is a project manager with TRC. His focus is on California residential new construction programs. Nick manages the design and implementation of the California Advanced Homes Program, California Multifamily New Homes Program, the SMUD Smart Home Program, and the Roseville Advanced Homes Program. He holds a BS in Chemical Engineering with a specialization in energy and the environment. Nick, why don't you take it from here?
Thank you, Allison, and I want to thank everybody for taking time out of their day to join us. And just to let you know, we scheduled this for 2 hours. We actually did this panel as a presentation at the CAHP conference earlier this year. And we were a little cramped in an hour, so I scheduled this for 2. I don't expect it to take the full 2 hours, but I just wanted to make sure we weren't rushed if anybody had any questions at the end. So today, Allison just went over the introductions. I want to talk a little bit about why Windows and why now. I'm going to give a brief history of Windows, and then unfortunately, Mozzie was not able to make it today, so I'm going to cover slides on the CEC's outlook on Windows. And then Robert will talk about bringing innovations to market, and Brad will discuss the Alpine Windows products. And then we'll have time to take some questions and answers. So why Windows? Well, as code gets closer to Z&E, residential compliance is becoming much more difficult, and the compliance points associated with high efficiency windows are becoming much more compelling when coupled with the available incentives. Another reason is in order to reach the 2030 goal of commercial Z&E, high performance window adoption will be necessary if we're going to get high-rise buildings to meet that Z&E goal in 2030. Robert's going to talk a little more about the advancement in technologies. But just to give you an idea, dual pane windows were top of the line back in the 80s when we were all listening to cassette tapes. There has been major advancements in technology since then, and the window industry, while it has kept up on the research side, we haven't seen much adoption of this newer technology, but it is available. And another reason is the massive energy impacts. $25 billion per year in energy impacts is wasted through windows naturally, and 10% of building energy, and that's 4% of all energy use in the US, is lost through windows. Next slide. All right, so now a brief history of Windows and where we've come, how we've got to where we're at. Until the energy crisis in the 1970s, most windows were single glazed. With the energy crisis came the adoption of dual pane windows, and in the early 1980s, through Department of Energy funded research, low E, or low emissivity coatings were developed. By 1989, the National Fenestration Rating Council was formed with the mission to standardize Windows thermal performance ratings and labelings. By the mid-90s, low E glazing reaches greater than 50% of US sales. Now we fast forward almost 30 years to 2017. Double E glazing is still holds the main market share. They have truly saturated the market at 96%. And that only leaves 2 to 3% of the market share is with high efficacy windows or high efficiency windows. So that's something we want to see if we can make a change in the next few years in that number. Next slide. So now I'm going to talk a little bit about the current incentives through the CAHP program and how they affect Windows. So in 2019, compliance in the state of California will begin to be based on the EDR, the Energy Design Rating. So the current CAHP program is based on the improvement of the Energy Design Rating over the standard design. So high efficiency windows, can improve your EDR in certain situations in certain climate zones by as many as 5 or 6 delta EDR points. This could lead to more than $1,500 in incentives just by raising your base incentive to get into the program. Not to mention the $200 additional bonus that we're currently giving for windows with a U factor of less than 0.24. And another major bonus of the windows in the current program is that CAHP incentives are now paid on a lot by lot basis. Due in most part to glazing percentages on various faces of the building. Certain orientations are going to have a much better delta EDR score than other orientations, and the windows will help negate that that effect, because the majority of that effect is caused by the heat loss through the windows. So now I'm going to talk a little bit about the effect on compliance of the windows. So in this chart, you can see the baseline energy use of a home. So we took 4 different homes with 6 different measure packages, and we ran them all with high efficiency windows, and then we ran them all with baseline windows. So what you see is the difference in the averages in each climate zone. And as you can see, the compliance margins range anywhere from a half a point of compliance all the way up to nearly 14 compliance points. And the windows that we ran for these and every climate zone except for 1, 3, and 5 is a 0.20 window, 0.20 U factor and a 0.20 solar heat gain. And then in 1, 3, and 5, where a higher solar heat gain is more appropriate due to the heavily heating needs that are needed in those climate zones, we run a solar heat gain factor of 0.75. These numbers were actually given to us by the CEC, and these are the values that they are possibly looking at for future prescriptive values in one of the future codes. So now I think Allison, oh, sorry. Now I'm going to talk a little bit more about the incentives for the windows. So windows are what we consider a hybrid bonus. So what that means is windows are modeled. So they receive a performance incentive just naturally in the model that will help either to get into the program or will help raise your incentive if you already qualify for the program. So you get that added incentive to your entry level, and then on top of that we offer a $200 bonus for single family homes, and we offer a $75 per unit bonus for multifamily homes in the CMF&H program. And those cash bonuses are for the current 2017 program year. We are currently doing some more in-depth research into these windows, and that bonus may be changing to $1 per square foot in 2018. So please hold on that one. So next slide. We're going to look at the true value of performance windows in the program. Next slide, please.
Actually, let's just launch our poll real quick. So we want to know if anyone has ever installed triple pane windows before, if you've considered doing it, or if you've never thought about it before. So I'll give you guys a few moments to respond to that question. All right. So it looks like most people have never considered installing triple pane windows, but some have considered doing it. No one on this call has installed them.
Okay, so on that note, let me explain why you should possibly look into considering these windows.
The slide.
That one, thank you.
Okay, sorry.
So the $200 cash bonus does not tell the true story, and this goes back to what I was saying about how the windows affect your delta EDR, which affect your entry incentive. So as you can see from this example home, when it was modeled with high efficiency windows, we got a delta EDR of 7.2, which led to a base incentive of 1,050, and we get the $200 bonus for the high performance windows. When we go over to the home that was modeled without high efficiency windows, we see that that delta EDR drops to 5. The entry incentive is now only 600, and they're no longer getting that $200 bonus for the high performance windows. So we can see in this case that the $200 bonus doesn't really tell the true story, that the true incentive of the windows in this example actually turns out to be $750. So I just want people to be aware that that $200 is to bring awareness to the windows, but the true value of the windows within the program comes in that base incentive and that bump in your delta EDR for installing high performance windows. So now I'm going to cover a few slides that I received from Mozzie at the CEC. Unfortunately, poor Mozzie is in Hawaii today, and he is unable to join us. So I will be covering these slides. Next slide. So first, Mozzie wanted to cover what the proposed 2019 standards are going to be and what the changes are going to be. So for high performance attic, we're going to go to R19 and severe climate zones, moving from R13. High performance walls are looking to go to a 0.043 or a 0.046 U factor, and that's down from the current 0.051. Windows are going to move, prescriptive windows are going to move from a 0.30 U factor and 0.23 solar heat gain. That's what they're moving to from the 0.32, 0.25 window. And QII is going to prescriptive requirement. Tankless water heaters are already a prescriptive requirement. What Mozzie's trying to get at here is we're getting fewer and fewer compliance options for trade-offs, which makes glazing more and more palatable of an option. And with builders asking for additional compliance options, high efficiency windows with a U factor of 0.20 and less can really get you some major compliance points. Next slide. So this is showing some of the energy impacts. This was a sample home, 2,700 square foot home, and climate zone 12. As we can see, the effects of the high performance attic were 3.3 EDR points. The high performance walls are 2.3. And as you can see, high efficiency windows, they can give you the same results as is high performance attics, high performance walls. The high performance window at a 0.2 U factor brings the delta EDR down 2.3. And with a 0.5 U factor, would bring the EDR down to 3.3. So the window upgrades are comparable to attics and walls. And I think that's just what he's trying to show here, is the fact that that is although we want you to do all of these measures, that the windows is a viable trade-off for some of these more advanced construction measures that some of the builders tend to want to shy away from. Next slide. So currently, high efficiency windows are available through several manufacturers. There are several Energy Star partners in California that are producing these windows currently. The costs are higher, but we think with the compliance that you're getting and the incentives that are offered, that they're still reasonable, and that as we push adoption, as my panelists will speak to, the price of these should drop pretty drastically. And hopefully we'll have some additional incentives available in the coming years to help spur that along. And now I'm going to pass the presentation over to Robert Hart from Lawrence Berkeley National Laboratory, and he's going to talk a little bit about bringing some of these new innovations in window technologies to the market. Thank you, Robert.
All right, thanks, Nick. Okay, yep, like Nick said, I'm going to talk about some of the research that's being done at LBNL. And being funded through the DOE and other measures in the US, just to give an idea of the kind of scope of research and where the technology is on high-bay insulating windows. So yeah, so I guess I got to start out with kind of a why are we doing this, and Nick touched on it a little bit, and I'll kind of reinforce it here. Of course, we look at this and we say, well, there's a lot wrong here. There's a lot of problems with the envelope, not just the windows, but the roof is pretty bad. You can see the garage door and everything else. Go ahead and go to the next slide. So yeah, you know, the building envelope, it affects peak load, the load shape, the grid, and really what we look at is something like $25 billion a year, and that's just from the windows. Of course, all the other parts of the envelope as well make a big difference. You know, it translates again to what Nick said: 10% of the building energy, 4% of total U.S. energy. Now, we already have a solution to this, and it's up there. The quick and easy solution here would be just get rid of windows in general. Of course, none of us want to live in this building. Go to the next slide. We want windows. We want the comfort, the view, daylight, fresh air, you know, egress, energy, everything that comes along with a window that we want. We don't want to work or live in this kind of sealed building. So what LBNL is doing and other researchers, we're trying to find a better solution. So I'll talk a little bit about some of those research activities. Go ahead on the next one. So what LBNL does is we really focus here on this kind of right end of this figure that I have shown here. What this is just basically annual energy use for a typical home. This one is in Minneapolis. And what I did is I separated out the baseline building energy. So kind of everything else through the envelope and HVAC system is in the dark gray. All the energy associated with the windows is on the upper half and the light gray on the left-hand side. So what you could think of as a typical kind of most of the windows out there on the market right now, this double clear window. It uses, you can see how much percentage the window uses compared to the rest of the envelope. You know, the typical window that's being sold now, like Nick said, greater than 90% of the windows, kind of the basic code minimum window and Energy Star window right now is this double OE, and you can see it makes a big impact. You know, basically cuts that window energy use in half. There's this Surface 4 coated low E window that's become fairly popular in recent years, and that was kind of designed to meet this kind of U 30/30 window, the 0.3 U factor, 0.3 solar heat gain. And that window, you know, it makes a little incremental gain, but really where LBNL is focused on is this last kind of few bars, triple pane windows and future technology. So we're looking at development and adoption of how do we get these windows out on the market, and ultimately in that future tech version, we're looking at how can we transform windows until this energy user into a net energy gainer. So along with all the other building research that's being done to lower this kind of baseline energy use that's outside of windows, how can windows make an impact in that baseline as well? Let's go ahead to the next one. Thanks. So just to look at some of the funding that's coming into this field, and as a DOE national lab, majority of our funding is through the Department of Energy. I've kind of highlighted that if you follow the green bars down, where most of our funding falls under is this Emerging Technologies Division. And there's quite a few projects being funded through this Emerging Technologies that are Windows related, and I've listed the current active projects here. And if you're interested in any of these, I think the presentation's available in the slides. I provided the links here. You can click on any of these and find out more information and more details on all these different projects. But I highlighted or bolded some of the LBNL specific ones here, where core LBNL and NREL funding. So this is funding that really keeps our specialized labs running. We have quite a few labs that really aren't practical for a commercial testing laboratory to have, but for a research facility, in developing these windows and developing the standards in our software that's used for NFRC rating, they're very important to have. So DOE helps fund that through the core funding. Some additional projects, the AERC, which is Attachment Energy Rating Council, which has been going on for a couple years. which is basically the NFRC, if those are familiar with that, the National Fenestration Rating Council. This is basically the same thing that's being developed for attachments. And it's going to be focused more on actual energy savings rather than NFRC is the kind of U and SHGC metrics. The AERC is going to primarily be focused on an EP rating or energy performance rating. And the U and SHGC will be in there as well for those of us that are really interested in that. And another one I just want to highlight out of that is this smart automated program. And this is kind of a combination of those two fields. Where this is a project that we just finished with Pella Corporation, developing a adding smart automated controls to one of their triple pane, highly insulating windows that already had an integrated shading system. So what we were doing is trying to figure out a way to make the shade do the right thing at the right time. And that project just finished up recently, and final report's coming out pretty soon. Just to highlight a couple more kind of research activities, ARPA-E funding through the SHIELD program, which is single pane, highly insulating, efficient, lucid designs. I think they worked hard on that acronym. This is I don't know if people are familiar with the ARPA-E program, but it's kind of the DOE's high risk, high reward program. So these are programs that have a high risk of failure, but if they do work, have a very high potential reward. And this applies, the idea behind this funding was to have you make this large portion of the market that still has single pane windows into more highly insulating designs at a low price. How do we do this without replacing the whole window? But the designs or the technology that can come out of some of this research can really be broadly applied. It won't just necessarily apply to single pane windows. It can apply to double, triple pane windows as well. And then the last couple things here, market transformation area. So outside of the technology development, of course, they're Building America, many of you are familiar with, Energy Star, of course, everyone is. And then working with energy codes and where that goes. So go, next slide. And of course, DOE isn't the only one doing any funding here. Just mentioned Energy Star. Of course, EPA runs the Energy Star program, and then Energy Star Most Efficient program for Windows has been introduced in the last few years, kind of incrementing the performance of Energy Star Windows. California, since a lot of us are from California here, we're very aware of the net zero goals for 2020, and then EPIC funding. So some of this work that I'll be talking about today for project specific is partially funded by the CEC's EPIC funding. So California is definitely very involved in this area as well. And nationwide, so utilities through CEE, the Northwest Energy Efficiency Alliance as well. NEA has done a lot of funding in these highly insulating window area. And just kind of follow up, it's of course not just the US, the world. Of course, Northern Europe has their standards are almost baseline standard now as triple pane windows. But even in North America, so NRC Canada has just introduced their goals for U factors of windows. You can see these aspirational goals that they have up. 0.28 for 2020 and 0.14, so an R7 window by 2030. So these are pretty strict requirements. Of course, you can't meet these goals with just these standard double panes that we have on the market today. Good, next slide. So give you a kind of a market snapshot of where we are now in the US. So this is basically, we scrubbed the NFRC database, looked at their certified products. So this is from 2015, but it hasn't changed much since then. And looking at vertical sliders, which is this kind of double hung, single hung window, which is kind of the most common window out there. Just looking at just a simple frequency plot based on the U factor. And you can see that based on what manufacturers have actually had certified, triple pane windows are about a quarter of the products, which is pretty amazing to think about, that a quarter of these windows that are certified, which means they technically can build these windows today. But then if we look at what the sales volume is, which is these kind of blue bar charts going down, that's 2% of the market. So 25% of the windows being certified, 2% of them are being sold. And of course, what Nick talked about is 90%. I have 90% here, you had 96. So it's greater than 90% of the market is these double pane low E windows, which is your code window. You can see that it peaks right around that U factor of 0.3. Pretty standard code around the country. And then there's a few double clear out there, just kind of replacement windows of pretty small market. So why aren't these windows selling? And that's the big question that we saw in the poll, that you guys aren't installing these, manufacturers don't want to build them. So what does the industry say that, why aren't these windows selling? And the kind of typical response we've been getting when we talk to the industry, and this is primarily manufacturers, is that they're too heavy, they're too wide, there's no demand for them. And I guess that goes along with the others, that they're too expensive, the return on investment is too long. And really, after talking to so many of these folks and learning how they have everything set up, I have my own translation to what all this means. And really, it's that they're too invested in their current designs. They're very well set up for building their standard double pane low E window that they've been doing since the 80s or late 80s, early 90s. They do it really well. They put a lot of money into these designs. They don't want to change. And of course, the second one is, well, it's not required, so it goes along with it. They don't want to change. So if you don't have a reason to build a better window, why would you do it? So that's kind of what I'm going to talk about now is well, how do we do it? So what's the roadmap of getting us from this typical double pane low E window to get to something better? So kind of do that through an example of a project that we've recently started, which is this thin glass triple IGU. So Nick talked about the kind of market adoption, or how we went from a double clear to a double OE, which is, roughly translated to kind of R2 window to an R4 window. And the thin glass project that we're working on now is, well, how do we go from an R4 to an R8? And so what we want to do is kind of follow that same market adoption process. So the same process that we used that was so successful with the double clear, kind of try to implement that same approach for this thin glass triple. And kind of what the market adoption, not really curve here, but this chart looks like is, the first 20% is this big innovation push, technology development, show these early adopters, like the folks we're talking to that are listening here, that this technology works, that it's good, it saves energy, you put it in these advanced homes. Once you can do that, you can start lowering the price, and then you can get to that 20% adoption. Past that, you're to 60% is this market pull, which is once you can show that the costs are low enough, you can and you have NFRC ratings or ratings like that, and Energy Star, these kind of polls, these market incentive polls, you can get much broader adoption. And then of course, once you have codes and standards, you get to where we are now with typical low E windows, which is the greater than 90% adoption. Go ahead. Thanks. So what is a thin glass triple IGU? So here's an image of one that we built, just a corner sample that we share around the office. Why are we building it? It's high performance, so getting the triple pane performance without the weight. So the thin glass is very light. A single spacer, just like with the double pane, you use one spacer, you don't have the extra process to do it. The idea behind this is that it's a drop-in, so it's the same width as a double pane. You don't have to change so they don't have to change your frame, which leads to that last point of the low entry cost. Really the only idea behind this is that how can we make it so that the manufacturers in the short term don't have to redesign frames. And that's really important for them, is because they're all set up for this specific window and this frame, and they have so much investment in these frames. In the short term, how can we get increased performance without them having to redesign? Go to the next one. Thanks. And of course, this is such a good idea that we thought about it 25 years ago. So you can see this patent disclosure from Selkowitz. So Stephen Selkowitz, who recently retired, led our program for many years, had this patent in 1991. at the time, thin glass didn't exist, but so I think the drawing here is for using a polymer type unit for the center glazing, but the ideas are the same. So this idea has been around for quite a long time, but it really was before its time. The market wasn't ready to handle something like this back in 1991. We believe it is now. So go on to the next slide for me. Thanks. So why is it going to work now? So we actually, besides 1991, in 2012, we thought at the time that with this big influx of thin glass that was hitting the market for big screen TVs and cell phones and everything else, there's a ton of thin glass out there. It's a product that's finally ready to go. We attempted this sort of project back then, and in the end, it ultimately didn't go anywhere. And really, because of this chart that you're seeing here, is that at that time there was really only one supplier of thin glass. Everyone knows the Gorilla Glass and Corning, and it was quite expensive. For TVs and cell phones, it's a very high margin business. That doesn't work with Windows. There's a lot more square footage per product. You can't have this high margin. So it ultimately was just too expensive. Add that with the cost of Krypton gas. When we do these thin triple glazings, you really need to have this Krypton gas fill because we're making the gap width suboptimum. And the only way to counteract that is to use the Krypton gas, which brings us back into a more optimum gap width for the gas. So at the time, the Krypton gas, so go back to that last one just for a couple more seconds here. So the Krypton gas was also quite expensive at the time. It was heavily used in the halogen lights. And of course, we own this since that time, the LED market has really taken off. The market has dropped out for the use in lights. It's a commodity gas. The price has dropped out as well. So there's the price for Krypton gas is very low now. And since then, the thin glass market is ballooned. There's many manufacturers making the thin glass all over the world. They're looking for new markets. The margins aren't as high as it was before. We're looking instead of prices of $5 a square foot in the 60, 70 cents a square foot now for these glasses. So I think this chart really explains why we think now is a good time for this product. And of course, what that means with that drop in price is that we can show a payback. So that big concern for window manufacturers is there's not an ROI. Well, now we think that we can see one in the future. And this really applies to all climates. And I think that's an important thing to note is that it's not just in Minneapolis, which we all think is that, these cold climates or anywhere else, or for California, I guess we can say Tahoe. It's not just cold climates. And I have one bar here for California that I guess is kind of purple, which actually has the quickest simple payback, and that model is for Los Angeles, so LAX weather data. And how can it possibly have the quickest payback in something in such a mild climate is really that electricity costs are astronomical in California, right? Compared to Minneapolis or somewhere else, or throughout the country, the air conditioning, electricity costs are so high that using these high energy efficient windows actually can even have faster paybacks than somewhere else. Go ahead, next one. So that kind of covers the technology development and a little bit into the market poll, but there's a couple other things I just wanted to bring up about these other benefits of these windows that we really make the case to owners and maybe those of you that are designing these buildings and building these buildings is kind of the case to make to the owners, and why would they want to go to something like this? So a couple charts here. One is condensation resistance, and that's always a big one for the concerns, especially when you go to these tight buildings where you don't have a lot of air leakage. You can have moisture problems inside the buildings. Thin triples and triples, I'll kind of lump those two together, have much better condensation resistance, right? The inside surface of the glass is going to be warmer because you have a more insulating surface. You have less chance of getting mold development, anything like that. So that's always a big selling point. And then, of course, comfort temperature. So the winter comfort temperature in this chart going down basically is what the outdoor temperature could be while you're still comfortable sitting next to the window. So as we, double clear, it's obviously somewhere around 10 degrees Celsius, but triples and thin triples, you're getting 20, 25 below Celsius, where you can still sit next to the window and be comfortable. And that's, mainly based on the radiant temperature of the glass that you're sitting next to. So this is really important, for square footage of your house or comfort in your house, being able to sit next to these windows. Go ahead, next one. And I'm just going to briefly mention, I've been talking about your house and residential, but of course this also applies to commercial. And same on that last comment is being able to stick your desk next to a window. And commercial buildings more and more go to this, like this image shows, these kind of all glass facades. Gaining back that square footage next to the window is a big deal. Every square footage of usable space is important. So the case that you can make, to architects, engineers, and builders is really this kind of, as you increase your window size, by using a highly insulating window, you can decrease this perimeter HVAC. And one example that I really liked was this given by Chris Mackey at Payette Architects, and this image and numbers are from him on a project they worked on, which was the incremental cost they got for upgrading from a double pane to a triple pane was about $550 a square foot. But doing so eliminated their need for perimeter heating in this project. And the perimeter heating and specifically in this project was $53 per square foot. Massive savings, right? It made this a no-brainer to do. So these are some of the arguments for commercial building as well as residential buildings. Next one. And of course, California gets more and more concerned with this duct curve. And the resilience of the grid and how do we deal with these peak loads and really anything we can do to make the building envelope more insulating, make it a more stable load is going to help out this curve. So go on to the next. Okay. So where do we go from here? So this next one. So this project that I'm talking about using this example, this thin glass. It's been going on for about a year. We've been doing a lot of this technical validation, some of which I kind of briefly touched on in here. And we're moving into more this process with supply chain partners and window partners. So for the next year or so, we're working with these two groups. So kind of halfway in between phase 1 and phase 2 of identifying supply chain partners that are interested in working with us. And window partners, both large and small partners that are interested in these type of designs and how they would implement them into their buildings or into their products, in existing products. So, any large manufacturers or medium and small manufacturers, how can they bring in and work with the supply chain partners that are willing to supply products for these, and what would it cost for them to change their lines to build these products and get them on the market? So that's where we are right now for the next year or so. And I highlighted over here on this technical evaluation side, really for this group, which I think maybe by the poll was the right one to highlight, is that once we get past that phase where we work with manufacturers and have a product and we can build something that's ready to go onto market, it doesn't just automatically sell right away. You really need to demonstrate its use. And a lot of the folks here, these net zero advocates, anyone that's building these low energy buildings really wants to, know that these products work before they go out and specify them in all their projects and that sort of thing. So internally we do laboratory testing, but really, in the end, we're going to be looking for places to do this technical evaluation with demonstration projects, utility incentives, those sort of things, to bring these products out in demonstration projects to prove that they work, that they can be done at the prices that we say, and that they have the return that they say before we get that, reach that 20% adoption of that first technical, adoption that we talked about with the curve. So one last thing, and kind of threw this in at the end, is as a few months ago we had the Passive House conference in Berkeley. And we had some folks from Passive House Germany come by our office, and we talked to them for quite a while, and they were very confused at why triple pane windows were so expensive in the US. And, one of the things they talked about is, we build triple pane windows. That's what we know how to build. So how could it possibly be cheaper? It's actually more expensive for them to build a double pane window. So this, goes back to that previous chart I was showing is, what's our goal here? It's, well, what's the window industry going to say, regarding the lack of double pane sales? And in 5-10 years, what are they going to say? And switching that curve about triple pane sales, well, eventually there's not going to be in demand. They're going to see that as double pane windows are uncomfortable. There's condensation problems, and really they're too expensive to build. And of course the translation stays the same, right? They're too invested in their current designs. If that's a triple pane window, then if you're built to build triple pane windows or better, a different type of window, that's what's going to be cheap to build. And then of course, eventually, once code catches up, if it's required by code, that's what they're going to build as well. So I think that's all. Oh yeah. So just finally, if you're interested in engaging with us on any of this, or you're interested in more, there's some contact info. Again, we're looking for not immediately, but we are starting to talk to people about demonstration projects and that sort of thing. So I think I'm turning it over to Brad to talk more about application, I think, of these kind of triple pane windows.
Thank you, Robert. I'm Brad Began. I'm going to speak a little bit about Alpen High Performance Products, who we are, what our products are. This is not a sales call at all, but I'm looking forward to kind of sharing with you where high performance windows manufactured in the U.S. currently are. I'm going to spend a fair amount of time as I go through these slides talking about what I consider to be our unique perspective on the U.S. window manufacturing market. We sell windows across North America, primarily in the United States and primarily in cold weather climates from coast to coast, and we have for years. And I think we are often in competitive situations with other suppliers of high performance windows, and we've got some interesting, unique perspectives that I want to share as we go along that I hope you'll find interesting. And then I will speak at the end of this about some of the objections and I consider myths around high performance windows that I'd like to try to expose or at least talk about. Who is Alpen High Performance Products? Alpen has been in continuous existence in one form or another for over 3 decades. We're based in Boulder, just outside of Boulder, Colorado, where our window manufacturing facility is. Our glass is made in our Denver facility, our insulated glass units. And for all 30 years, we've been considered one of the leaders and innovators in the world of high performance glass windows and doors. We are the world's most experienced fabricators of glass units using suspended coated film technology, and I'll explain more of what that is. It's also frequently referred to as heat mirror. We call it suspended coated film. We are proud of the fact that we have empirically the highest performance NFRC certified windows in the entire NFRC database with God knows millions of entries. And although it varies from month to month, roughly about 1/3 of our sales are commercial and 2/3 residential. What are our core product offerings? We sell windows, glass, and doors. Our core technology and core competence for decades has been the manufacture of ultra high performance insulated glass units. Once again, we're the world leader, most experienced manufacturer of glass units using suspended coated film technology. We began our existence as a glass manufacturer. We are also manufacturing a line of super insulating fiberglass windows and doors, and we've in the last year introduced a fiber reinforced UPVC European style window and door. What's a European style window and door versus our more typical North American style window? North American is thinner sight lines, tends to be hung sliders, awnings, casements. The European style window has a much broader sight line and tends to be inward swinging tilt and turns, hoppers and such. Once again, as I mentioned, we're continuing to evolve, innovate our products, and I think we're proud of the fact that despite the fact we're having an awful lot of fun selling windows, doors, and glass right now, more than we ever have, as our sales continue to grow very, very quickly. We've always been a bit of the window geek, I think, in our heart, and we're proud of it. We try to evolve, integrate the very best of the best products, constantly evolving our products. In June of last year, as we recertified our windows again, as we have to every 4 years through the NFRC database, we're able to, using the best current technologies, finally achieve a very commercially viable and available and affordable full frame R10 window, a 0.10 U value that we market and are having great success with. And then as we've rolled out the European style fiber reinforced UV PVC window, what we call our tie roll series, we actually one-upped ourselves and offer a R11 full frame window, the highest performing window available by any U.S. manufacturer, and to our knowledge, perhaps world manufacturer. How do we get to these high performance categories? With our Zenith, or our fiberglass window, I wanted to kind of show some of the elements of our product. Next slide, I think. What we do is we look at every element of the window and what causes a window to be a higher performance. We try to optimize every element. If you can move to the next slide, that would be great. With our R10 window, we integrate, in this case, open back pultruded fiberglass frame, which, as many of you know, fiberglass is an outstanding insulation product itself relative to some of the other very strong, capable frame systems like aluminum. We use an ultra high performance super insulating closed cell foam. We, in our Zenith North American style series, use a quad pane or double film 1 3/8 glazing pocket. We use the latest and greatest in soft coat low E glass technologies. Once again, we use low E coated films, and we use a number of different gas fills depending on what we're trying to do. In the R10 window, we're using Krypton. We use a lot of argon, and then we also are integrating stainless steel spacers in our highly sealed IG perimeter. So it's a combination of all those very easily commercially available products that allow us to kind of now continually evolve. We offer a full line of products. Virtually everything we do is triple or quad pane. We kind of started at our 5 or 0.20 U value and get better from there. Let's go to the next slide and talk a little bit more about suspended coated film insulated glass. Suspended coated film, I want to talk about in the context of sort of the history lesson that we talked about earlier. Glass, as many of you probably know or may not know, as a history and political science major, I love this stuff, as I do. I sit amazed at our federal political system these days. But the Romans really innovated single glass technology in the BC era. But it was the revolutionary R2 window that was first patent issued in 1865 that now serves as sort of the basis of U.S. window manufacturing. Suspended coated films, interestingly, many people don't realize, were initially developed almost simultaneously with soft coat low E. It's really very similar technologies. The soft coat low E's that were originally developed by Cardinal Glass back in the mid 70s used very similar technology to what was developed by Southwall Insulating Glass in the same time period, with sputter coated low E deposits in our case, films, and in the more normal glass or typical low E glass that you think of on glass products. It's very much of the same technology, the same development. In fact, Southwall and Cardinal Glass sued each other to try to figure out who was first in developing low E. My understanding is neither one of them won. Calls it a draw. If we move to the next slide, what we do and what we're able to do with film, uniquely to film, is we don't have the weight of triple glass. We use the suspended film that is tension leveled in a heating process to either create the equivalent of triple films in a single film dual cavity product up to quad or even quint cavities. With our tie roll European style window, we can put up to 2-inch insulated glass units and get some really fun combinations using that wide glass. But once again, it's the combination of using low-E coatings, suspended coated film, both on glass and in film, and gas filling using argon primarily, an awful lot of krypton, and then also occasionally xenon. Insulating gases are a very interesting subject I want to just divert from in a moment. There are many schools of thought on insulating glass units. The vast majority of dual pane insulated glass units use argon gas. Argon gas has its best performance, at least in the US, the way we measure product in the US, in a 1/2-inch airspace. Hence, that's why we're seeing so many dual pane units that are 3/4 of an inch to 7/8 of an inch, typically, because they're designed to optimize around that air pocket with argon gas. Argon, many of you may or may not know, seems like an exotic gas, but for what it's worth, it's virtually free. It's a very readily available product. We pay as much or more for the rental of the tank and more for the gas filling equipment and expertise than we do for the actual gas. Krypton, which optimizes in a 3/8-inch airspace as far as it gets its peak performance, is a more expensive gas, but as Robert alluded to earlier, has dramatically dropped in price, really changing a lot of the economic structure of sort of where krypton gas, which used to be considered an expensive sort of luxury item at more than $1 a liter, is once again probably confidential information, but in the event that it might help people be a little more inquisitive about such things, has dropped by 75% from that number recently and continues to fall as LED continues to dominate sort of the growth of the light market. It's very interesting world. Xenon optimizes in a 1/4-inch airspace. It's kind of a crazy, funky, wildly priced and swinging gas. It's used in outer space exploration and other things like that. But after 1865, 150, now almost 160 years later, we finally have readily available and sort of widespread manufacturing ability to offer triple and quad pane super insulated windows. I want to go back to one of Robert's slides that we're going to talk about more in a moment. People think about triple pane as being not readily available. And I really want everybody to understand this because it absolutely amazes me. But virtually every single major window manufacturer that I'm aware of, having gone back and recently researched this, has triple pane options readily available in their product line right now today. They not only can make them, but they have windows that can supply U values sub 0.20. All of them do. Many, many versions of them. Suspended coated film sounds techy. Is it really a niche? No. As I mentioned, not at all. It was co-originated with low-E glass decades and decades ago. More than 250 million square feet of suspended coated films been installed in North America by many other fabricators, but I think Alpine is a leader in that area, and hundreds of thousands of projects. The entire Empire State Building has suspended coated film. The award-winning Packard Foundation, which is one of the highest performing buildings in the world, headquartered in Palo Alto, has suspended coated film. Spectacular building. We just finished supplying windows to Boulder's Common, a net zero spec commercial building built here in Boulder, has our windows and suspended coated film. We have our product in the Davis Research Station, owned by New Zealand or occupied by New Zealand and Antarctica, and we've also have our product in the highest point in Greenland. Sounds fun, sounds interesting, but the vast majority of our product goes down to everybody on Main Street, USA. Use flip slides, I would appreciate it. And really, although we have the great luxury of going into a lot of really, really fun projects throughout North America, our core market is homes, buildings, all throughout North America, much like the ones that you'll go home to tonight, whether it's a multifamily, single family home, not necessarily the huts, but it's a very widespread adoption. Let me talk about our core business strategies, which is something not typically provided on webinars, but we're really proud to talk about it. What we really are trying to do, and I think we're doing very successfully at Alpin, is to bring mainstream high performance products. We do everything we can, and we work our fingers to the bone, lowering our costs and trying to pass those costs along to the consumer through efficiencies, new technologies, growth, investment in equipment, whatever we can do to compete toe-to-toe, day after day with all of the mainstream windows that many of you are familiar with, may have in your homes or buildings or otherwise use. I think we're being very successful at it as we grow. We're also at the same time extraordinarily interested in what the world of possibilities are and trying to look where things are moving to as we move down through our visions of the world. And we're very, very excited that we're now able to uniquely, I believe, produce commercially viable, affordable, and ready for prime time net positive energy window systems in the marketplace. What is a net positive energy window system? This is a window product through orientation and through differentiation along the glass and the performance of the north, east, south, west facing windows that produces more energy through passive solar gain than it actually lets out through the windows. We have products that in fact insulate better than walls, but with some new developments, some of our higher performance windows, we now cross over in virtually every climate with the ability to offer net positive energy window systems. And it's further accentuated by the fact that with use of dynamic glazing on the south elevation, in other words, electrochromic blinds, movable blinds, whatever the case may be, we can provide, once again, in any climate across the United States, a series of products that create more energy than let out without the use of blinds, without the use of turning down your thermostat 40 degrees in the winter. It's very fun and exciting. And we're also intensely interested and spend a lot of time talking about how to optimize windows with building shells, mechanical systems through a variety of partnerships and products, frankly, that we're integrating together, because having a high performance window with a low performance wall or a bad window install with a good wall, or having an oversized HVAC system is really just sinful in many respects relative to being able to get the best economic value for a particular project developer owner. We also do a lot of fun stuff. This is what we do to keep ourselves busy. We're always interested in new technology. We do daylight redirecting technology. We just put that into a commercial project where it refracts the light on clear story lights and sends it back deep into the building. We've used our glass with thermochromic products. We've done some PV integrated windows. There's some really fun and exciting things going on there. And we've also just developed and put through our process and have sitting out on our glass racks right now the first electrochromic glass unit using heat mirror suspended coated film technology, where we're able to get a U value for that overall unit probably down to the 0.12, 0.13 range, but with a manageable SHGC that can move from super solar heat gain friendly with probably a 2.4, 2.5 up to a 0.5 plus SHGC. It's a very exciting development. So let's talk about why the U.S. mainstream windows industry fights to stay in this dual pane performance range. Once again, you've had some discussion about this. It's mystifying to us. We can't tell candidly whether we like it because there's so much demand out there and the company is prospering as a result of that, or why we can't get everybody else to do this. It's really a very mystifying thing. As I mentioned earlier, we do compete all day, every day, probably more per capita than any other company in the country with European imported windows, and we have for a decade. While we've seen U.S. Market share in hundreds of millions of dollars fall to European imported products that are perceived as high performance because they do build good windows over there, but have a certain cachet around high performance because they're triple glazed, inevitably. We have not seen our main name brand U.S. manufacturers provide competitive products. It is shocking to us. That market share has grown, and we seem to oftentimes fight a battle by ourselves in these competitive situations. And we're doing well. We're doing really well, but this market is remarkably big. Where is the U.S. manufacturers? This slide and the next slide, this was when we spoke live in Palm Springs, and the last 2 weeks was probably 4 to 5 weeks ago. We were exhibiting at 2 large national trade shows, the U.S. Passive House show in Seattle and the show Robert referred to that was in Oakland for the PHI group. These are very large national trade shows for incredibly fast-growing niches of high-performance buildings. And we counted between the 2 shows 13 companies of the many dozens that were showing different products that sold windows. Every single product there featured triple glazed product windows. Of all of those companies, 2 manufacturers, us and one other U.S. manufacturer, and that U.S. manufacturer had almost all dual pane, 1 triple glazed product on their stand. Everybody else used imported products. Unbelievable. Talk about common objections to using higher performance windows. Cost. This is what we hear over and over again, and we're constantly surprising people pleasantly with the cost of our windows, but it's a perception that triple glazed windows cost too much. As I mentioned earlier, almost every window manufacturer in the U.S. Manufactures right now triple glazed windows, and they have those to offer. And our industry's dirty little secret, nobody wants to tell you, is the cost difference to produce triple glazed product over dual pane, including labor, material cost, is on the high side, $2.50 to $4 a square foot. I know for a fact that for a large manufacturer with any scale, it's significantly less than that. Understand that's cost, not sale price. The sale price is typically much, much higher, multiples of that. We don't understand it. Common objections to using higher performance windows, again, cost. If, as I mentioned earlier, you're optimizing window performance, wall performance, you could easily offset that added cost of triple glazing. Here's an example, a real live example. We have one really terrific developer out here building state-of-the-art net zero energy ready homes that's developed a 2x4 double wall, 9.5-inch wall with using 3.5 R value windows because that's sort of what they've always done. In one design that was equivalent of 41 HERS score, which qualifies as a net zero energy ready home if you add PV to it. It had 19% window to wall ratio. They had to, when they developed their house, they had to develop this R40 wall to get to that level. It's a great wall system, very expensive. Framers aren't super excited about framing it when they can do many more projects faster in the current environment. But if they simply use R5 windows, the R value can be reduced to R22. R22 easily achievable using 2x6 construction with a little bit of exterior insulation. Dramatic cost and material differences, labor differences, easily pays for higher cost windows. Those examples are all over the place. Common objections to higher performance windows. This one always cracks me up a little bit. Triple glazing weighs too much. It's hard to install. Although we use suspended coated film products that don't weigh any more than triple or quad units, we also manufacture a broad line of triple glazed products for those that have that preference. And there are multiple suppliers of suspended coated film and product in North America. We're not the only ones. We think we're the best. We've certainly done it the longest, but it's readily available. However, using existing glass technology, easily available, easy to manufacture, they're not that heavy. Let's talk about it, and let's talk about it empirically, though. It may surprise you to know that the average size glazing of a window for a very large window manufacturer, I was able to interview and share a lot of information, non-competitive information, but just to confirm what we know to be the truth, is 4 square feet, maybe a little bit lower. In California, you have tons of sliding windows. That's your biggest product, and your average glazing size is probably smaller than 4 square feet. But let's use that as just a benchmark. The average weight added for a true triple is 6.4 pounds at 4 square feet. Larger sizes, way more. Sometimes when you get really, really big, you get it moved from 1/8" glass or even thinner glass to 3/16, and you add a little bit more weight. But really, let's talk about what's 6.4 pounds. Just to give you some perspective, 6.4 pounds is the same as 2 larger than normal human brains, typically are 3 pounds, or a malnourished miniature dachshund that'll typically weigh 7 pounds. That's not much. You really can't use that as an objection from my perspective. And Robert alluded to it earlier. We couldn't agree more. Why don't we have more low-cost U.S. manufactured high-performance windows in the marketplace? They're readily available in Canada. They're readily available, in fact, the standard in Europe. But when you go to U.S. manufacturers, everybody can make them, but particularly some of the larger name brands that are leaders, that are out there sort of dominating opinion and dominating sort of that who's going to lead first and who's going to produce what, don't do it. There's no carrot. There's really no upside. We talked a little bit about California incentives recently. Those are phenomenal. What's going on in California is phenomenal, and it gives us great heart when we look at some of the places in the United States, including out here in the Rocky Mountains, New England, the Mid-Atlantic, but particularly along the West Coast, Pacific Northwest, and especially the leadership California is providing with incentives and carrot. It's just not that big, but more importantly, nobody makes them do it. Everyone's content with Energy Star performance. You can achieve that barely with dual pane performance. When there was a move to move Energy Star in colder weather climates to a higher performance standard, it was as if the sky was falling relative to the lobbying that took place to make sure that was happening. There was really no dollar reason for people that are in the mainstream to vary from what works well. Rebate incentives do work in northern Colorado. We have some phenomenally innovative utilities, municipalities, Boulder, Fort Collins, and other areas out here, and we know that rebate incentives work. We join a lot of projects that are taking advantage of incentive rebates, and they're frankly fairly significant, as illustrated by these that Efficiency Works, which is a collaborative of 5 local utilities, offer out here. Once again, we are having a lot of fun with triple glazed products and above and high performance windows. They are not that much more expensive, and we like to think typically not more expensive. They are readily available. It's really up to the market to demand higher performance, but force your suppliers. I don't care if we get the sales or someone else gets the sales, but please help us bring the U.S. window manufacturing market to bear and force them, ask them, hold their feet to the fire. You can get triple glazed products easily tomorrow. The initial quote may come back higher, but let them know you know what the gig is and make them provide the products. They are there. We just have to either pull them or push them. But we're having a lot of fun at Alpine, and appreciate the chance to have a discussion with you. Nick?
Thanks, Brad. And I want to thank Robert as well. And just a couple thoughts before we start taking questions. Going back to Robert's slide about the carrot and the stick. So as I discussed earlier, the incentives are there. They may be getting a little more robust soon. As far as the stick goes in the codes, code is moving towards these more efficient windows. I know that the CEC is engaged in research. I know the IOUs are engaged in research. And I think it's pretty safe to say that we should be expecting to see the prescriptive U factors and solar heat gains dropping pretty drastically over the next couple code cycles. And then the no reason for having no cash. Like I said, we have the incentives now. And the other thing that we really didn't touch on during this presentation that really needs to be taken into account, especially in the residential sector, is the sizing of your HVAC system. These windows will lead to a smaller HVAC system, which is less first cost for the builders. And the other savings is, and this goes back to one of the slides that Robert had on the commercial building with the heat around the perimeter. That's even true in residential. If we get a high performance window in the wall, we've lost reason to run that register, have to run that register all the way from the unit to the exterior wall. We can have much shorter duct runs when we don't have to put the registers under the windows. Those shorter duct runs lead to not only cost savings, but it also leads to less energy loss through those ducts. So it's another factor that we want to take into account when we're thinking about the benefits of the windows. But I want to thank my panelist, and I think we'll open up the call for any questions that anybody might have.
So we don't have any questions right now, but we did want to launch one more poll while the questions come in. So if everyone can respond. We're just wondering if anyone's now more likely to consider installing triple pane windows after hearing today's presentation. All right, just a few more moments. Okay. So it looks like the majority of attendees are now definitely interested in installing these, and a couple are still unsure, and some still do not wish to go down this route. So thank you for your responses, everyone. We do have a couple questions coming in. So here is kind of, so I had a friend putting a window in and put him in touch with Altman. He came back and told me the cost is double. Can you explain this? It's a retrofit window and they're not particularly interested in energy efficiency. So yeah.
Sure. Well, you know, of course, every example, the devil's in the details here. We'd love to know sort of what that is. That's really not been our experience. That's frankly very, very unusual. But whoever the friend is, I'd love for you to put them in touch with me, and if we can understand the details. That's not our experience. We go toe-to-toe with a lot of the major name brand manufacturers that use dual pane, and we're highly competitive. Where we tend to be more expensive is with retrofit vinyl dual pane windows that are fairly ubiquitous and have a broad concentration, or a broad variety of sort of, I guess, attributes. There are some really, really, really inexpensive dual pane vinyl retrofit windows that I think are just, you know, frankly, lower performance that, you know, I frankly very rarely would ever see a double the cost thing, but sure love to respond in detail and provide sort of more insight. It's really not been our experience, but I can't respond beyond that. It surprises me, but it is what it is.
We'll be glad to put you in contact, Brad, for sure.
All right, so next question. We spoke a lot about incentives for multifamily or tract type developments, but what about individual property owner incentives?
So the incentives that we talked about today are particularly for residential new construction. The same incentives would be applied to a custom home if you're just building a single new construction home. As far as retrofits go, I am not aware of any incentives for retrofits, but I can check into that. I work particularly in residential new construction, so I don't want to speak out of turn, but I am not aware of any. If anybody on the call is, any of the utility representatives that would like to correct me, please feel free to do so, but I am not aware of any for existing buildings.
All right. So regarding interaction with HVAC, Title 24 no longer requires HVAC right sizing. How much does that hurt this cause?
Well, I think it might have an effect on the modeling side, but you're still you still, if you size it properly to the home outside of the model, you would still be purchasing a smaller sized unit. So I don't think that has a lot of bearing on the cost effectiveness of the windows and that side of it.
Okay. Okay, so some other feedback. So regarding, I think it was Brad's comments on triple windows, or for triple windows are looking more viable because I work with individuals with narrow properties, and the high performance walls especially are tough because you lose too much square footage to wall widths. That may have been more of a comment, but feel free to chime in if you'd like, Brad.
Okay, yeah, that's good to hear. I think in, once again, very dense environments, we are seeing a tremendous appeal for higher performance windows. Frankly, building costs are high. Every available square foot is critical. And although we do business in very rural areas, we have a heavy concentration in areas that are very densely populated. With wider triple glazed units, not just our windows, but others, there's also a secondary benefit that comes naturally with sound attenuation, and urban environments is especially important. The number 1, 2, and 3 things you can do to reduce sound travel through a window is increase air gap. Then also by adding layers and other dissimilar glass sizes, you can do some remarkable things. So I'm glad to hear that's certainly consistent with our experience.
Good. Okay, so some more feedback. You discussed the added cost for triple pane quite a bit, but what about the other attributes needed for R5 windows, such as Krypton fill, insulated frames and spacers, and third coating?
I could speak a little bit to that, and then certainly defer to the other panelists. There's some interesting dynamics. People are typically either making their own insulated glass units as a window manufacturer, but an awful lot of window manufacturers utilize, on the residential side, a very, very large insulated glass unit manufacturer. That is a really, really great company and does tremendous things, but they are deeply, deeply invested in a manufacturing process that optimizes dual pane windows. They utilize the same high performance spacers we use. They produce triple glazed units, frankly, very automated at a fairly remarkable cost, but gas filling is a remarkably challenging process for them, because with argon gas the way it is and Krypton gas being more expensive, they've figured out a way to automate gas filling by filling entire chambers with argon gas and somehow sucking it into the insulated glass unit, which is maybe impractical with Krypton gas because of the relative cost and the fact that argon is free. So they've got to fill glass units with Krypton, and they do, and they can, and the cost of Krypton gas has gone through the floor by doing it this old-fashioned way, which is with probes, actually putting the gas into glass. I don't know whether most anybody that buys Krypton, and they certainly buy a lot more than we do, although we buy a lot, has seen this cost of Krypton fall through the floor with LEDs dominating halogen lights in that market. And it's really changed the dynamics of the glass market very quickly. Understand this, and this is a very important fact. On the commercial side, We do a lot of commercial projects and glass-only projects, and we've got the largest insulated glass unit manufacturer, fantastic company. Again, on most of the skylines of the United States, you'll see their glass. We do lots and lots of projects with them. They just invested, I thought I heard $500 million specifically to manufacture triple glazed units in a highly automated fashion, because on the commercial side, they are trying to be the dominant leader. And I think the commercial side, we're seeing it move much faster than the residential side. Once again, I think if either the big name brand windows or the IG manufacturer that supplies most of them really take that leadership position, you'll see a dramatic change in the market very, very quickly.
All right, one more question. What would be the impact of vacuum between panes versus the gas fills? Shouldn't vacuum perform better?
I can take that, Brad, if you want. I mean, so yeah, vacuum would perform better, but it's impossible to hold the glass panes apart without something in between them. So the vacuum insulated glazing, and we've been involved with quite a bit of research with that over the years, and maybe for the last 20 years is always about 10 years out, or maybe even the last 30 years, it's about 10 years out. We've done quite a bit of research on it. Lots of different companies do quite a bit of research on it. There are some existing vacuum glazing out there on the market. It's quite hard to find, but it's there. Mainly produced in Japan. There's some companies in China making it and bringing them in. And then there's a few large glass manufacturers, like I said, been working for the last 10, 15 years, US-based ones, trying to get their product on the market. It's a very challenging thing to do. The idea seems simple, but it's actually quite difficult to make a very long-lasting, good product. So that's why you're seeing it take some time. There is still research going into these. I think if you look at my slide, there's a vacuum, a VIG project on that I mentioned in there. So if you're interested in that, you can go on the DOE's, Emerging Technologies website and look at their funding from that specific project. But there's many more as well. So not just funded through DOE, there's some basic science grants going into some of these projects. We're involved with quite a few at LBNL. So there's lots of ideas for VIG out there. It's progressing, but again, it's not something as immediate and that someone is out there like Brad's company or any other manufacturer that's building these now on the market, readily available certified units.
Just a highly practical comment. As I told you, we're window geeks. We love this stuff, and we're constantly trying to understand and bring to market and commercialize all of the latest and greatest technology. Vacuum insulated glass has been very, very promising for a long time, but somewhat like the lower cost electrochromic glass is just always just around the corner. And we found a technology that we had a seminar we went to recently that looked very promising. And I said, sure, we'd love to experiment as we do with every glass unit. And they sent over a 12-page non-disclosure agreement, which I ended up not signing, but I've never seen anything quite like it. And it was from an Asian country, and we could look at their technology and try to maybe put it in Windows and see if we liked it and all that kind of stuff, as long as we paid air freight for the samples to come over, and then we return them within 30 days after our testing. And roll my eyes, how are you going to commercialize that? We just want to get Windows into practical commercial applications. And yeah, we got a business to run, and we're making Windows, etc. So it's great technology. Someone's just got to make it commercially available.
All right, so those are all of the questions for today. I just want to thank Robert, Brad, and Nick for all of your knowledge today. We have an upcoming CAHP webinar on December 5th that I just wanted to let everyone know about. It's going to discuss energy efficiency strategies for the state and legislative changes that are happening to support these strategies. And they'll also discuss the 2019 code and prescriptive requirements for the building envelope, HVAC, DHW, and PV. And you can register on the CAHP website. So again, thanks for joining us, and we'll see you on the 5th.